Everyone, my name is Mohit Kumar Sharma and I'm currently pursuing the Masters in Cybersecurity from New York University. Today, I will be presenting my research to all of you that I've done on a topic called DDoS detection at application layer. So let's take a look at the problem statement that we have tried to solve in our research paper. So the problem is that we were trying to solve is how we can detect DDoS attacks at application layer efficiently and with more accuracy in real time. But why this problem is important to solve? There should be some motivation factor behind that. So let's take a look at some facts that we have gathered from different websites. So on the right hand side, as you can see, there is a chart. It's a part of the Cisco annual report. And this chart shows the number of DDoS attacks that we have seen in multiple years. And if you observe the chart, you will see the number of DDoS attacks are increasing per year, which means at the end it is increasing the attack surface. And it is giving the chance, or I would say that it is giving more chance to our adversaries to attack those machines that are out there that are vulnerable. So they can form a botnet to perform distributed denial of attack or different kind of attacks to our machines that are still vulnerable. So how we can solve this issue? Before we talk about any solution, let's also take a look at a web application architecture and the workflow, how it looks like. So in this diagram, as you can see, we have three areas. Untrusted area in red color, then we have external trusted boundary in dark green, then we have an internal trust boundary in light green. Starting from the internal trust boundary, it's an area where some components trust with each other, have trust boundary, or I would say that have trust relationship with each other, so they can communicate freely. And in this boundary, we have two components. One is the web server, where we are hosting our website, and the other one is database, where we store our all of data records. Then we have an external trust boundary in which we have internal trust boundary plus the genuine user who will be sending the genuine request to our web server to access his or her data. Then outside of this region, we have untrusted area, which includes anyone else who doesn't have proper credentials to our website, or any attacker that who wants to take advantage of our website. They are also part of the untrusted area. And in this untrusted area, as you can see, we have a botnet or bot network, which consists of the bot controllers and the bot itself. And the bot controller is someone who basically will be sending the commands to the malicious compromised machines that are called bot. And then these bots will be sending the malicious traffic to our web server. And then they will keep sending the malicious traffic to our web server until it's loaded, overloaded. And there will be a time when our web server will crash. And it could also possible our database would also compromise or crashed. In that case, it will bring down our business. It will cost us money. That means we need to solve these issues. But how can we solve it? Do we have any existing methods that we can utilize to solve these kind of issues? Definitely we do have, but they have some limitations. So let's take a look at what are the existing methods that we have today and what are their limitations. So if you see, today we have proactive frameworks that we can use to detect misconfigurations within our systems. So we can protect our system from these kind of attacks, first of all. And then we also have frameworks that can help us to categorize the DDoS attacks in different categories. So we can create the solutions based on a particular type. And then we have some detection methods that are based on DTMC algorithm. So it is a kind of algorithm that takes the user input, then it extracts the meaningful data out of it, generates some patterns using static properties, and then it will decide if there is an attack or not. And then we also have some handling techniques that based on these detection methods that we have just discussed. But all of these methods, all of these frameworks have something in common in terms of limitations. So all these solutions work based on an assumption, work based on a fixed set of properties. And they use the static properties to analyze the user behavior. So their predictions are limited. It could be right, it could be wrong sometimes. And then existing detection method doesn't support the new anomalies or the attack patterns that we have been seeing recently. So we need something that supports everything, that supports the dynamic properties, that supports the dynamic pattern generation. So hence, we propose a solution by creating an algorithm that will use the datasets generated using profiling of our application, different endpoints, and user behavior, using the custom traffic filters and aggregated threshold of patterns. And all these will be done without affecting the availability of our application. Let's also understand what this extra dataset means. So these datasets basically will be generated by monitoring our website users, how the user access our websites, individual endpoint consumption monitor, and also monitoring our network consumption in real time. We will be also profiling our application, their respective endpoints, and the user. And at the same time, we will generate patterns for our application, their endpoints, and users. We will also create custom traffic filters to separate the legitimate traffic from the fake requests that we will be getting. Then at the end, we will put a proxy server with a web application firewall in front of our web server so we can protect our web server from the malicious requests. So rather than sending all the requests to the web server, the requests will be coming through the proxy server. Let's take a look at the possible implementation that we could have. So we propose a detection algorithm. And the pseudocode for the algorithm seems like this. So we have a step 1 where we'll start executing our code. Step number 2, take threshold value from the user and then run it into the background. Step number 3, set base threshold for different pattern types that we have. Step number 4, call individual programs that are part of the same detection algorithm that will generate the patterns based on different dynamic properties. Step number 5, aggregate all the thresholds that we have got from different patterns and then get aggregated threshold. Step number 5 again, then check if the aggregated threshold exceeds the given threshold the user provided. If it does, then notify the user for the attack detection. Then they can take the proper step to mitigate that issue. If not, then just use that data for updating our existing patterns and models. So we can also have some patterns that also are able to recognize the new anomalies, the new attack patterns. And then 6, keep running that process in the background so it can monitor all the traffic in real time. Now let's take a look at the detection patterns and aggregated thresholds. So in this diagram, as you can see, we have different patterns in different colors. And then we have aggregated threshold in green dots, or I would say the green dashes at 75%. So if the aggregated threshold exceeds the user given threshold, that means there is a DDoS event or DDoS detection that we have detected. Now let's take a look at the architecture again after adding a solution in our architecture. As you can see, now this time we have put a proxy server with our detection method in front of web server, so we can protect our web server from the malicious traffic. Now all the malicious traffic or any genuine traffic will be flowing through proxy server, and at this we have our detection method which will be monitoring all the traffic, and if there is any issue, it will detect it and will let us know. It will only allow the legitimate traffic to go to web server. Now let's take a look at the findings. So when we did our research or doing the research, we found some things that we need to consider. So for this solution to work, we need to have a scalable proxy server with the web application firewall, so we can make sure there is no single point of failure in our architecture or in our framework. Then we also need compute power for our algorithm, because this algorithm generates a lot of data, this algorithm analyzes a lot of data, so we need a lot of compute power to do that kind of processing. Then we need a storage, a faster storage where we can store all those data sets, and then we need an indexing mechanism that we can use to dive through that data. And then we'll need a dashboard through which we can visualize our data, we can see what are the patterns are coming in, how we are detecting it, and visualize any kind of data sets that we have. Then we also need to make sure we don't train these models too much using fake data. We train these models using production traffic patterns, using mirroring of our traffic. And then we also need to make sure not a single property, I would say a single property should not have too much control over the whole pattern or the whole model that we have. Now let's take a look at the future work that we will be doing as part of this research going forward. So we need to implement this algorithm into one of the modern programming languages so we can take the advantage of today's functionalities and features. Then we need to train our model using the proper amount of genuine and fake requests so we can have a balance of both. So our patterns will be able to recognize both legitimate requests and the fake requests, or I would say the DDoS event attacks. Then we need to decide the weightage of properties and their contribution into the pattern generation so we can have a control. Okay, not a single property rule out the whole pattern. They should have the proper weightage between them, among them. Now, if you have any questions for me, or if you have any feedback for me or my research, then please reach out to me at GitHub at mksha and at LinkedIn at mohit-kumar-sharma-341380116. I hope you learned something out of it, and thanks all. That's all from my side for today.